Hey everyone. So today we're going to continue on our discussion on functions of several variables. So the last thing we did, we talked about something called level set, and we managed to draw the top four, well, not the top four, but four different levels of this surface that we try to come up with. The 0 level, the first level, the 1 level, 4 level, and 9 level. So now the question is, how do I actually complete the surface? So notice that by looking at these four different level set, we realize that our surface actually have a concentric circle as the cross section. Now important to understand, it's just a circle, nothing inside. It's not like this, it's just a circle. So concentric circle. So if you think about it, most common suggestion is that the surface will look like a cone, an upside down cone. Because if you think about the cone and you cut it open, the cross section will be a disc, which definitely will form a circle on the outside. The problem is that's not how this surface look like. So the question now is the following. By doing level set, we can have an idea as to what the surface will look like at each level parallel to the xy plane at a different z value. But we actually don't know what this surface look like from the front or from the side. We know what it look like from the top because we have a top down view right here, which kind of give you the concentric circle, but we don't know what it looked like from the front or from the side. So that's what we're going to try to figure it out. So to figure that out, what we're going to do is something called, oops, something called coordinate curve. Okay, so what is a coordinate curve? So coordinate curve is basically, as the name suggests, is a curve that we go try to figure out how the curve look like based on one single coordinates that we want to study. So imagine the following. Let's say given a function f that map from Rn to R. So we know in this case the function f would be x1 f of x1 x2 dot 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 to xn, which equal to some value, some output value which I call y, but of course in our scenario, which I would explain to you, but this is in general, the coordinate curve for x sub k is basically the function f of x sub k equal to y, where x sub k is the only, make more room, the only independent variable while all other independent variables are treated as constant. So therefore, what a coordinate curve is basically imagine that your function have only one independent variable. So by isolating this one single independent variable, we now allow us to actually form a curve. Now, why is it a curve? Well, if you think about it, if I have n that many independent variable, but only allow one to change, then essentially what I have is a single variable real value function, and we already know a single variable real value function is the same type of function that you learn in BC calculus, and we know that those form a curve. Now, to properly illustrate this, maybe we can try this for our function. So in our case, let's try to do this. I guess I can do it here. That's probably okay. Actually, you know what? I will leave room for the drawing. So let's do a little bit. Let's do an underneath here. All right. So for example, let's say we have a function f of xy equal to x squared plus y squared, which equal to the output z. So in this case, there are two variables. So this tell me two independent variable. Therefore, there are two types of coordinate curve. In this case, one for x, one for y. Z remain the output. That's the key. Okay, so now let's show you what the coordinate curves are. So let's start with the coordinate curve. Oops. For the variable x. So what does that mean here is that for variable x, we will go and let y equal to some constant b. We don't know what this constant is. All we need to know is that y is not changing, but y is a constant. So therefore, it will now change my function to become f of xb, which is equal to x squared plus b squared equal to z. And so now that form what we call the coordinate curve. Now, several things interesting about this coordinate curve that I want to point out. Number one, this coordinate curve is not fixed because it depends on what b value is. Number two, this coordinate curve actually relates the single independent variable, in this case x, with the single dependent variable z. So therefore, this coordinate curve actually exists on the xz plane. Okay, now notice if you look at this equation right here, you should note that x squared is a parabola. And you should realize that the plus b squared actually allow us to shift the graph vertically up. So therefore, in this case, the function that we have will actually form this kind of curve. This is z equal to x squared. Z equal to x squared plus 1. And z equal to, you know what? Let's see if I can do this. Okay. No, I don't want that. I want these two things. There you go. There you go. Now they fix that. And we'll fix this. There you go. Okay. That looked pretty good. And that equal to z equal to x squared plus 2, and then on and on. So therefore, in this case, the coordinate curve for this function on the xz plane will kind of be parabola. Now, here's something also very interesting to note is the following. Even though when I join this, I'm changing the b square value to be different value, and therefore the parabola move up. But notice that the b square value is actually influenced by the y value. So therefore, in this case, you can also think of each of these parabola. Not only does it move up, it also move outward in the y direction, because I have to change y in order to change this number. Okay, now how does that affect the graph? Well, I'll show you once I try to put all of these together. Now, with that being said, now maybe you can try to find the coordinate curve. Oops. The coordinate curve for y. So if you want to pause for a minute just to do that yourself and then try to check my answers, you could. Okay, so therefore in this case, to form the coordinate curve for y, I'm going to let let x equal to some constants. So I'm going to let x equal to some constant a, and therefore what I have is f of ay, therefore become a squared plus y squared equal to z. So that's my coordinate curve. Oops. All right. I note that this is also a parabola, but notice that this parabola is actually on the yz plane. So therefore, I'm going to go and draw that next to it so they can see this is the yz plane. And the parabola would basically be exactly the same thing. So this is z equal to y squared, and then maybe this one is z equal to y squared plus 1, and then maybe this one is z equal to y squared plus 2. Oh, maybe I shouldn't write it over there. Maybe I'll write it here. Z equal to y squared plus 2, and so on and so forth. So now, once again, this had the same exact idea. So if you look at this graph right here, the y-axis should stick out from the origin toward you. And if you look at this graph, the x-axis should stick out from the origin here and also stick out toward you, or actually into the screen, depending on which way the orientation work. So therefore, as these parabola move upward, they also move into and out of the screen toward you or away from you. So it's kind of hard to visualize that, but that's basically what happened here. Now, the question is, can we now put all of these together to form the surface that we want to draw from here? So now I notice the following. If I look at this two coordinate curve, I know that if I look at it from the front, it will be a parabola. If I look at it from the side, it should also be a parabola. It's actually kind of symmetrical. So therefore, if I now want to draw this graph, I can go and try to draw this. So now let's see if I can draw this without messing it up. So if I look at it from the front, that would mean that I'm looking at it from on the YZ plane. On the YZ plane, it should look like a parabola. Just like that. That parabola would actually be z equal to y squared. Now, what happened if I look at it from the side? When I look from the side, I'll be looking at it from the xz plane. And the xz plane, I will probably be looking at a parabola that go out to front and then out to the back. Just like that. And that parabola is z equal to x squared. So therefore, if you would imagine that this picture is actually look like a parabola spinning around the z-axis, it's actually often referred to as a paraboloid. Okay? Now, if you want to know how this looks like, I actually do have a picture that I download from the internet. So let's see if I can actually insert it. Let's see. I guess picture. Oh, right here. Found it. So this is basically how the surface look like. So it's kind of hard to visualize it, but you have to see that this circle is kind of like the top. You're looking at the inside of the surface, and you can see all these parabola on the side. That's basically what the levels, what the coordinate curve are, what these are. Okay, and then you can see that the top kind of form this circular shape. That would be what a level set is. So literally, basically, try to look at it from the top, from the front, and from the side. And you see that from the front or from the side, you see basically a parabola, but from the top, you see circle. So in a sense, you can imagine that you have this surface and you basically cut it either along the XZ plane or YZ plane or the XY plane. So if you cut it along the XY plane, you're basically forming level set. If you cut it along the XZ plane, you're basically forming the X coordinate curve. If you cut it on the YZ plane, you basically form the Y coordinate curve. So that's basically how that works. All right. Now, in order for you to actually put a picture like this together, it does require a lot of analysis and try to figure out what it looks like. So we can definitely try another one and then hopefully give you a better idea. So let's see if we can do this one. How about we draw this function instead? Okay. How about, I guess I could probably ask you to do the exact same thing, okay? How about, let's say given f of x, or f, let's say map from R2 to R again, And as a matter of fact, a lot of the function that we'll be doing will be mapped from R2 to R. Reason? Because R2 to R give you a graph in R3, and that's probably the highest dimension we can actually draw a graph. Okay, any dimension higher than that, we won't be able to draw a graph. And let's say the function is f of xy equal to, how about x squared minus y squared? And then we let the output equal to z. Okay, let's say we're going to sketch the following level set. Let's say k equal to, I don't know, 0, 1, 4, 9, etc. And some of them actually might not work, but, well, I guess we can try and find out. Okay. B, how about let's sketch the x coordinate curve. And also let's try to sketch the y coordinate curve. And then maybe finally we can try to sketch the surface. I don't know is that going to work, but we can definitely try. Okay. All right. So let's go and give it a go and see how that works. So A. So let's do the level set. So let's start with the 0 level set. So 0 level set would be x squared minus y squared equal to 0. So that's actually kind of tricky to do. Okay. You know what? I'm actually going to do this. I'm going to change it. I'm going to do -2, 0, and 2. Because I actually realized that this can actually be negative, so let's pick some negative numbers. Okay. And they actually don't have to be, well, technically, maybe I do -1 and 1. Probably easier, because they do actually kind of need to be perfect square to make it easy. And yes, I know, -1 is not perfect square, but a perfect square, but you know what I mean when I do it. Alright, so let's do the 0 level set first, since I already written down. So x squared plus y squared equals 0. So this one actually kind of tricky, because if you think about it, that would imply that x squared would equal to y squared. And now here comes the interesting thing. The interesting thing is that student would say, oh, can I just take the square root and say x equal to y? Well, not true. The reason why it's not true, because when you do take the square root of this thing, this is what happened. When I take the square root of both sides, so let's go and draw that in. Then what happened is, you have to first realize that x square root of x squared, it technically is not x, but rather is absolute value of x. And when you take a square root of y, you also can have absolute value of y also. Okay? So therefore imply that absolute value of x would have to equal the absolute value of y. So therefore it actually gives out quite a few distinct possibilities. The distinct possibilities are the following, is that would actually imply that I could have a positive value inside, which become a positive value on this side, or a negative value on this side and a negative value on this side. And therefore actually give us 4 distinct possibilities. That's kind of come down to 2 different points. Okay, and that would be this. It would mean that x can definitely equal to y. If they have the both, meaning they're both positive, both negative, they could both give you the same exact absolute value. But you could also have them both being opposite value, because let's say if you have 3 and 3, then absolute value of 3 would definitely equal to absolute value of 3. Now that's easy. But if you have 3 and -3, then -3 absolute value and 3 absolute value also are the same. So therefore actually form 2 separate equations at the same time, and therefore give you this level set. It's actually give you two lines. So that's how the level set look like. In this case, the level set actually form two lines that form an X. Okay. Now we can definitely do the second level set, which is the -1. So let's do a -1 level set. And yes, your level set can be negative. That just means that your level set is underneath the xy plane. So if I do -1, that would mean x squared minus y squared equal to -1. Therefore, imply that y squared minus x squared is equal to +1. And you have to realize what this equation is so that you know how to draw this. This is actually a hyperbola. What is a hyperbola? It's basically two parabola kind of opposite of each other. So in this case, because y squared minus x squared, it actually gives you a hyperbola that open up and down. The interesting thing is to identify these 2 points. These 2 points are actually 0, 1 and 0, -1. And these two are basically y squared minus x squared equal to 1. Or actually, you know what? I'm going to label with the original equation. Actually, it doesn't matter. I'm going to label it y squared minus x squared equal to 1. Because that's kind of what it manipulates to. Now we can do the next one, C. So that would be one level set. All right. So one level set would be where x squared minus y squared equal to 1. So that is also hyperbola. But this hyperbola open left and right. And these 2 points are going to be 1, 0 and -1, 0. And yes, some of you probably can guess that 1 and -1 are basically square root of 1. And so square root of 1 is +1, -1, but it's on the y. Because the y squared go first. And this one x squared go first. Or rather the x squared is the non-negative square. Alright? And that's how the parabola look like. Now, we can definitely do... Oh, there's no B or C. So that's just part A. Okay? So those are the level set. Now, as you can see, if you vary this value to be more negative, then you basically have a different parabola where these 2 points are further apart. So therefore, basically, you're pushing the two parabola in the hyperbola further and further away as you go down the level. On this side, when you make this number bigger, like let's say 4, then these 2 points will be -2 and +2. So therefore, the two parabola in the hyperbola will be further away from each other, moving away along the x-axis as they move up. So now, how does that look like as a surface? I don't know yet either, and I don't know you can visualize it. If you can, good for you. But I haven't. I don't know how to visualize it yet. But I do want to find out more information, so let's try to do part B and part C. So let's do B. So B, you want to do the x-coordinate curve. So remember, when you try to do the x-coordinate curve, what you want to do is let y equal to some constant, which I'm going to let y equal to constant b. And so therefore, what I have would be x squared minus b squared equal to z. So therefore, this is basically a parabola. Now, however, the interesting thing to know is that because b squared have to be a positive number, you always subtract a positive number to x squared. Therefore, this parabola can only shift downward. It can never shift up. Very similar to in this case right here, because it's plus b squared, this can never be negative, so therefore all your parabola kind of shifting upward. Okay? So in this case, it's actually kind of the reverse. So in this case, what I have would be a parabola that kind of shifts downward. So it will be on the xz plane. And here would be my parabola. and it will probably shift down like this. So therefore I could have z equal to x squared, that would be when b equal to 0. Z equal to x squared minus 1, that would be when b equal to 1. Z is equal to x squared minus 2, that would be when b equal to radical 2, I guess. And then we'll continue to shift down. This is the highest parabola in this group, and then they just go downward. Now, some of you can probably already guess. The y-coordinate curve actually behave very similar. We're going to let x equal to a. Therefore, we're going to have a squared minus y squared equal to z. So notice, technically speaking, you can think of it as negative y squared plus a squared equal to z. So notice that this shift is always shift upward because a squared have to be a positive number, plus a positive number will move it up. But the y squared actually have a negative in front. So therefore, actually make the level set to be something like this. Oops, that is z. This is the first parabola, z equal to negative y squared. And then you might have this one, which is z equal to negative y squared plus 1. So a equal to 1. So 1 squared is 1. And then you might have this one, which is z equal to negative y squared plus 2, where a is, I don't know, square root of 2. All right? So that's pretty cool. So now the question is, what does this surface look like? So actually it's not that easy to draw this surface, and it would actually look kind of like the best way I can describe it is look kind of like a saddle in a horse, on a horse, or a Pringle, like the potato crisps, not potato chips, because they actually not make from real potato. Well, they make from potato mash, so they have to be called potato crisps, not chips. Okay, but lucky for you, I actually have a picture of this. So let's see if I can show you what the picture look like. Yeah, it's right there. Ooh, okay, I don't know why it's so small. Let's see if I can fix this. Oh, actually, oh, there you go. So that's how the surface look like. You can definitely see the hyperbola on either side, and then you can see that the upside down parabola and then also the right side up parabola. So a little hard to visualize, but the key is that if you cut it across like horizontally along parallel to xy plane, you will basically see these pair of parabola on either side. But then if you look at it from the front or from the side, you can see that if you look at it from the front, you see this parabola. That would be the parabola on the xz plane. And then you can see, if you look from this side, you see the upside down parabola, and that will be on the yz plane. All right. Now, you will be asked to draw a graph to go through this process right here, forming level set, forming coordinate curve, and then try to sketch the surface on your next test. But the surface I'm going to ask you to draw would be a little easier to deal with than a picture like this, because this would be very hard for you to draw. So I definitely do not expect you to be able to draw something like this on your own. Okay, but something like this one you should be able to do. Okay, because it's right here. We did it. All right. Unfortunately, that's all the time we got for this video, and that would be the end of 4.2. Okay, and we'll go talk more about it during class if you have any questions. All right. All right. Talk to you in the next video. All right. Bye-bye.